Lagos is rising fast as a powerhouse for emerging technologies, while the trailblazers are leading the way. The new generation, that's the upstarters, are not left behind also. They are being prepared for the future challenges and opportunities of tomorrow. Hello and welcome. I am Dapo Aruwajoye. Welcome to Technifier. In our mission to discover and spotlight young minds that are doing great in AI, robotics, and innovation, we at Smair Foundation AI Robotics Innovation Hub here in Lagos. This is where hands-on training and experience in technology are put together to train young minds and build them for the future of tomorrow. Apparently today is their open day. Come with me and find out what these young minds are really up to. Hello guys.
Hello sir. Welcome to Smair Foundation. Today is our open house event.
Today is your open house event.
Yes.
Amazing. What are you guys up to today? What are you showcasing?
We're showcasing what we have not been doing for the past time of the year.
Let's see. What do you have here?
This is our robot soccer.
The Robo Soccer. What's this all about? Tell me about it.
This is our robot soccer, like when robots play football.
Wow. So you guys did this?
Yes.
Wow. Amazing.
We have is our Robo Soccer Arena. So this is a joystick pad. This is used to control the robots to play soccer. It's that simple. So the goal of this is to enable how you can make the robots control the ball from one point to score goals at either post. So you are seeing this like this. Good. So the objective is to make the robot move in different kind of manner using the joysticks that we have here on the gamepad to score a goal.
So what do we have over there?
Is our Robo Race Arena. So this is an arena that we use to design how a robot could go through different obstacles and overcome them, basically by going from this here, the ladder, over to where you have uneven ground and over to where you have that pivoting table. So the goal is to allow the students or anyone we are training to see how they can maneuver, and it will influence their algorithm of how they program the robot to be autonomous.
In the heart of the University of Lagos beats NIT Hub, Nigeria's digital powerhouse, powered by NITDA. NIT Hub empowers youth, builds ecosystems, nurtures startups, and drives inclusion nationwide, turning bold dreams into realities that lift millions.
I am Dapo Aruwajoye. Over the years, I have dedicated myself to amplifying tech voices and fueling startups from ground up. Now, right here at
NIT Hub,
Unilag, we forge a groundbreaking collaboration, explosive, purposeful, and unstoppable. MVP made in Nigeria transforms minimum viable products into most valued products, rooted in our culture and wisdom. MVPs to MVPs. Technology ignites the journey. Southwest Flagship Edition, awakening Yoruba-powered innovation through bootcamps in every Southwest state: Lagos, Ogun, Oyo, Osun, Ondo, and Ekiti. Every participant undergoes a metamorphosis, mentored, skilled, uplifted. Whether they win or not, lives are forever changed. And we are just starting. We will awaken this fire across every geopolitical zone of Nigeria, every nook and cranny. Founders, sponsors, visionaries, the moment is now. Join us. The fire is ready. Press the button. Let Nigeria lead Africa's digital future. Let's build our own intelligence, AI that truly understands us, native tech, sovereign innovation, MVPs to MVPs.
For more enquiries, visit www.mvps2mvps.com.
competition we are going for in Geneva is this one. This is the farming bot. And this whole thing started they started working on this late last year, around November. And it's been a lot. In fact, what the first one looks like, this is not this is not what the first prototype looked like. And we've seen the children work tirelessly. They're like, okay, first it should have a hand. Then someone comes and says, you know what, I don't think a hand is working so far, and then they're changing. So we've seen them go through all that iteration. We've seen them go through different processes. We've seen them quarrel. We've seen them fight. And, and at the end, look at it now. They are up there. They've been able to do something tangible, something that works at least. This smart home system came from the idea from a little girl that said her mom keeps complaining that she leaves the lights on in the house. As she came, and to her it was a complete, because that day we were like brainstorming. We usually use the ideation room for brainstorming, and we said, those things that are problems to you, just say it. And she said, my problem is that my mom is always shouting at me. Why is your mom always shouting at you? She said, I used to leave the lights on in the house every time. I used to leave the TV on. I used to leave the AC on, and it's burning units. And she said, we now said, okay, what do you think we can do to solve that? Someone else was like, what if we made everything, what if anytime I leave the house, the room, everything just goes off automatically? And then they start working on a smart home system. Everybody that had that problem, everybody that felt, yes. So one thing we learned from that is that most times you will not understand the problem like someone who has lived it. So these children have lived it. To them, they have lived the problem. So building the solution is something they can only build. They can build because they have actually lived that problem. You know the pain points best. So at the end, they built that, and it worked for them because now they could see, okay, and there's an alarm system. Anytime someone who comes in, if someone comes in that is not me, there should be an alarm. That's one person's idea. Another person's idea is if I leave the room, the light should go off. Another person's idea is if I'm walking towards to the corridor, the light should come on and go off when I leave. Something like that. And different ideas all came together. We said, it could look like a house. And then they built that. Then this other one, the smart dustbin, was another girl. And she said she doesn't like touching the waste bin. She felt there's too much germs. I don't want to touch the waste bin. What if the waste bin opens by the time I get close to it and I throw it in? And she was like, okay, we can do that. And she started working on it and build that. And that person now comes, why do I have to go to the waste bin? What if the waste bin comes to me? And normally that would be some people will say, oh, that's you being lazy, right? But I like telling them that if innovation is the father of invention, laziness is the mother. Because laziness would sometimes push you to do some certain automations that, if we're trying to be hardworking, we'll not be using cars. Because why wouldn't I just trek? My forefathers were trekking for how many different states? Yes. And the smart dustbin came out. We even had some people who come from people who work with Lagos state government, and they were like, waste disposal is a problem. What if we can automate it to separate between biodegradable waste and non-biodegradable waste? And we could start seeing different iterations that started from just a child that doesn't want to touch the dustbin. So you see, those are how almost all our projects are built. We usually start them on the United Nations SDGs. When we start with that, then they start iterating on that. And at the end, we see them do big things that would have started from small places. So when we go upstairs, we will now see the actual products themselves. Right, thank you.
So we're going to the lab.
We're going to the lab, yes.
The lab, let's come right. Yeah, this is where most of our hands-on and experimentation, this is where it happens. This is the grind, this is the table. This is where the iron, this is where the servo motors, the panels, this is where the students get to see if their idea is feasible. Because design and design feasibilities are concepts that you only get them at a higher level, but we're bringing it down in bite sizes for the children, and not just only children, industry professionals, undergrads. When they come here, they have a one-on-one experiment on saying, oh, this thing I'm doing, is it going to work? Okay, I have different means of making sure that they design. So first things first, we train them heavily on hands-on, but we also let them use virtual environments to conceptualize things. You cannot just immediately start building. Come on, some of these ideas are capital intensive, but can they simulate a virtual copy, save cost, save time, And if they need to make corrections, make correction on the physical object is longer than just using a mouse and a keyboard to make the adjustments. So we teach them how to do 3D modeling. We also teach them how to do circuit simulation. So instead of actually soldering with the soldering iron physically, they can do the connections virtually, test if that circuit idea is going to work. Then by the time they are putting it physically, it's just straight to deployments. That's cut down that time. So we are teaching them industry scaling mentality from bite sizes. Even when they write code, we have interfaces that is block by block. They don't need to understand all the typing and the syntax. They understand the concept. They use the blocks to make the program. They run them into, for instance, this one here is called Arduino Audio Block. It's a very simplistic design that we made, courtesy of our partnered company, Mechatron. So they help us in manufacturing this all the way from India, all the way from India. And when they bring them here, we test it and we use this in training the students. Sometimes we also send them our designs, they manufacture it and they bring it here. So this now, the students can use it to create a robot that can, like we saw downstairs, the automatic farming and seed planting and harvesting robots.
So what about this? What is this?
Okay, this now is another robot that is meant for obstacle avoidance. So now we are all talking about autonomous vehicles that will drive themselves. Now, how does that happen? If I stand in front of the vehicle, should the vehicle hit me? So now it can detect an obstacle, it can stop. You can even go as far as putting recorded warnings. Please step out of the way or passage, so that even if that person is not aware that he's obstructing a vehicle, he is now made aware. So these are how the students experiment to see if autonomous vehicles are something feasible. And so we also, if you see that arena course down outside on our compound, so if you notice, it's filled with a lot of things.
Yes.
Now, Nigerian terrain is not all smooth as you will get in Western world. So how can they test to see if it gets into a pot, will it come out? If it gets into an uneven road, will it be balanced? Will it not tip over? So these are how they visualize and practice and develop their own product.
So what's this?
So now this is an automatic fan system. So it's still in development. So the idea was, if the temperature in the room exceeds a certain comfortable state, can we just have the fan automatically turn on? Why need to turn it on? So it's now coming into autonomous humidity and room temperature regulation.
Okay.
It's a big word, but for these children, it's let the fan just on if you are feeling hot. Simple idea.
So to speak a bit into the competition, for example, they have built the prototypes that they've been working on for the competition, and I told them to bring our guy to come and explain to us the concept, like what we needed, what the competition required of us, and how they've gone ahead to try to work on that. So he's going to give us a brief demo.
So the Air for Good competition this year, the theme is to solve food insecurity. So first of all, we read the rule book and it gave us the exact measurement for this. We got this specific material at the bottom because the friction can change how a robot will move and how it turns. So what we did is we got a saw and we cut this, then we now chiseled it to this size. We now use the spray paint. It is inside that cabinet over there. So what we also did is we got colored paper and we used a marker to color the lines, which is where our seeds are supposed to go. The little balls over there that are blue are the water. So a robot stick will open this and the water will fall out to represent watering your plants.
So what's the entire goal that you're supposed to achieve?
The goal is to solve food insecurity because let's say you own a farm and the work is too much, you can get a robot because humans tend to make mistakes every now and then while a robot normally doesn't. So a demo of what we've been working on so far is this. So it turns and then it plants.
Okay.
So it's still a work in progress, but this is how far we've gotten. But it's a software where you can test realism. So this is a software that is meant to test what you've been building. Like before we even made what is there, our course over there, we had to make it on Tinkercad. So what you do is that there's also another function, like if you're building a robot, that can test it so that if it doesn't work, you know that there's a problem and you can change your design. Like this is what one of my mates have made, a ballerina, which we have 3D printed with a printer.
We made use of an ultrasonic sensor. It's a device that can determine distance. So when you go close to it at a certain distance, it triggers the mechanism to like open this bin for this person to dump. So now we are taking the step further. We want to now use infrared. So now, an inanimate object might be there. How would you determine if it's an inanimate object or an animate object? So we switched into IR sensors. So now this IR will be able to detect me, open, and even the mechanism is a bit smoother because now the children now understands, oh, using servos can be a bit cranky. It can startle people. Why don't we use stepper that is gliding so it's smoother? So now you see they're understanding how the product impacts who they are doing it for, or even them themselves. Is it better this way or? So that's how this one came about now. So this is an improved design. So I could, but I'm not done for my phone yet. So that's for this. This is one of the prototypes. So over here is the 3D printer itself.
Made by Bamboo Lab.
So these children are already familiar. Imagine how old he's 12 years old, going to be 12 years old, and he's already familiar with industry standard 3D printing because this is industry standard. This is not even for kindergarten or elementary. This is industry standard. And when it comes to printing, when it comes to making sure that their designs come out the way they want it, they understand all the concepts. So also here we also have more apparatus that we use in showing the children now robotics in industry. When you see the way cars like BMW factories are made, robots are the one handling it. So we use this to show the children how they can use robotic arm to automate industry processes. So this is actually a work in progress. I'll power this one right here. So this is the assembly line and the power distribution. Okay. So now at least they can understand if they are using a robotic arm to do sorting. Maybe a component comes out faulty according to the design, it is moved out or it is packaged for further processing. So we'll go over there. I'll show you some of our other prototypes. Now this is from primary school students. I think one of them, the dad's an electrical engineer, and he's always complaining that whenever there's a shop somewhere, it is the most difficult thing for them to find. It's the most difficult thing for them to find. So they've come up with a circuit, a very simple circuit. And how they got the inspiration was, we did a class where we showed them magnetic detector, how they can use a reed switch. Okay, how they can use a reed switch. This is the reed switch to like trigger sensors. So now the child was like, if this can detect magnetic fields and electromagnetic field, can it be able to detect where there's like any magnetic voltage leakage or whatever? Or even if there's magnets in like food or anything, or metals in substances that people are supposed to consume, it will make work easy, and they designed this. So the moment they take it close to something that is electromagnetic or ferromagnetic, it lights up an LED and they are able to detect it. It's a very simple design with that kind of idea. Imagine a child in primary school thinking this far, because you have to give them that catalyst, and that catalyst is already spread into a chain reaction of innovation and creative ideas. So over here is another rover. This is more
one of the prototypes.
This was actually one of their prototypes too. You can talk more about this. So this is using C++ code. Now C++, any programmer knows, is a handful, but we're able to break it down bite size to use blocks for them to program.
So tell me more about this. What does this one
So
do?
this is one of the prototype we initially wanted to use over there, but we decided to change the design. So this was the first one, that was the second, and then that was our final result of what we came up with. So we initially wanted to put something here, but the holes were too many and it's curved. But we used Arduino Nano, which is this, and we plugged it in with our computer with the code. So what we do is we write C++ with the help of AI and our brain, and then we'll now use a computer and plug it in the code to your Arduino Nano, but it didn't end up working out, so we made another one.
Amazing. So what's this one?
So this is the smart house prototype that they are working on. So the goal of this is eventually, if there is Let me do this. Eventually, how can you have an outside light that turns on automatically without you having to go and switch it on? So you see, the moment there is lack of sunlight, maybe dusk, you can see it comes on. Yeah. So this is a rough idea that they worked on.
So the whole idea is to...
Yeah, so if the sun goes down, automatically it comes up. If you turn up the light here now, it comes on.
Yeah, you can see because of the shade of my hand, if I put it over, it shines brighter. The farther away, the lesser the light. So when it's like getting midnight, it lights up a little bit, but when it's full dark, it will show the best.
Yeah. So this is also another prototype to that effect.
You can put your hand on top if you want.
So what they did here was they designed this on Tinkercad right there and 3D printed this. You can see it has our insignia.
So what does this one do?
It's the same thing. This is a smart street light.
And the light comes up here.
Yes.
The smart street light.
Yeah, so they're already having the concepts down, building it and testing it. Now it's working.
So this one saves energy.
Yes. So this battery has been on. This was done like 4 months ago. And this same battery has been there from day one. You can even see. So while it's not on, it doesn't have to burn power. When it's required, it burns power. So that's just it. So that's actually more. We have lots and lots of other projects. Here is where most of our vision becomes materialized. It's where all the cycles come alive. It's where everything starts to happen.
It's the lab.
Here we are passionate about bridging the gap, the technological divide that exists in our world. We're also passionate about turning coding and turning codes that we build into real life objects that are going to be useful to the society and also solve problems in society. So before now, you've seen people that say, oh, we do coding, but they only teach children how to code, but the children are not able to use those skills to solve real world problems. So one of the things that we're trying to do here is to see how we can bridge that gap. Whatever they build as a software should translate into hardware as well. And they should see how it is very possible to use minor things like sensors and all the other things that they are learning how to do to solve real life problems as much as possible. And we are very big on the SDGs.
We've started, first of all, we won for Lagos. We are moving to the national level, sometimes in May. And then our determination is that we will win at the national level to represent Nigeria. Not only that, we're also focused on 2 events this year. One in November, but 2 of them, we want to go with some of our children to those events this year. This year, for those events, we want to get them to see what's happening out there in the world. And then when they come back, the plan is that next year we will have, and some of our instructors here will be going with them. The idea is to make sure that we build a team that will be ready to take on the world, at any level. That's the plan.
Things I've learned is how to code on C++, how to practicalize what I've done by being on the hardware team and building such of the robots we're using in the air. Some of the things we've built is a harvester robot so that we can harvest the fruits like I've shown you upstairs. We also have a seed planter as well as the robot that will open the water valves.
So the automatic fan is meant to, like, when it's supposed to know the temperature of the environment, so that when it is above the temperature or when it's hot, it will turn on automatically. So no need for you to get up and turn it on, it's just on automatically. And me and my partner Chamanda, we made it with our other group.
So you don't have to get up and then stress yourself to turn on the fan. It automatically just starts blowing air.
So when you made this thing, how did you feel?
I felt happy and I hope that one day to actually come to life, especially in Nigeria.
So the reason why I'm here is to make the world a better place. They didn't just pick random people. I'm here because I was here for a specific reason, for something. And this is the thing I have to do. And I was chosen to make the world a better place. That's why I am here.
I came here for a reason, and the reason is to make Nigeria better, a better place through technology. So throughout I've been here, it has been so fun. My teammates have helped us. We have all built a lot of things, which we intend in the future it will improve Nigeria.
I've been here for 6 to 5 months, like they've said. My stay has been good. I've got to work with people I've not met before. I made new friends. There was a little bit of argument, but we have resolved that, and we came together, worked as a team to build our robot to make Nigeria a better place.
In future, I want to be a software designer. I want to build websites, games, and things like that.
I've learned how to code using Arduino Uno, using HTML, using C++, and I've learned how to do the hardware part of robotics, which is building robots.
When I first came here, I thought I would actually not fit in because I didn't know anything. I didn't really know much about technology. But by staying here, I've learned more than I knew before.
Right now, I've been registered for an AI for Good competition. So all of us have been working on a robot. So we've had a very nice experience.
Tell me, when you step out of this place, you step out, you go out there, how do you feel in front of your mates that don't even know much about tech?
Above them.
So this is where we draw the curtains on this exciting episode of the program. I've had an exciting and enlightening time with these wonderful kids at the Smair Foundation AI Robotics and Innovation Tech. And guys, I really want to appreciate you. I know you're going to do great in the world. Thank you so much. So I am Dapo, Aruwajoye. See you next time on TechnyFire.